We should take this off. Don't do anything with these until you receive instructions. You don't even have to look at it.
What? To the arc science? It's LNE. It's like always. LNE is CO1. It's that times the derivative of that.
You can just leave the extra ones in the back. Just leave the extra ones in the back. Okay, so the mastery exam is today. You must be. It's in the testing center. You must be in the door by 6:30, and then you can work until 8:15. But probably it will take half an hour at the most. Okay, you know exactly what it is. It's 25 short ones and 10 of the ones that you have from your list. Okay. Don't simplify. Just write down the first step and stop. Okay. Follow instructions carefully in terms of finding your 10. It's very simple, but someone couldn't do it last semester, and so they bombed the test because they just couldn't follow the instructions. Read carefully, okay? Any other questions about the mastery?
What do you mean, like in the test? Like
I mean, read the instructions carefully and follow the instructions. That's all I need to say. Hi, Megan.
Isn't it multiple choice?
No, you're writing them out. There's no multiple choice. Everything is written out. It has to be written out perfectly. Okay, you need to get 90% to pass. If you get 90% or better, you get 100. If you get 90% or better, you get 100. And that's worth, the weight of that is half of a regular exam. Okay, so that's significant. If you don't, then you're going to have to take it next Monday again. Okay, so if you don't get 90% today, you'd be taking it next Monday. Last semester, it was about maybe 60% passed the first time and 40% didn't pass. But you know exactly what the test is, so it's up to you, okay? All right, so let's move on to some new material, which we're still talking about finding a closed form rules for rate of change functions, but maybe just looking at something a little different here. So you've got if you open up your, get a browser window open on your laptop and go to assignments. And the first thing in assignments is the graphing calculator file. So download that and open it up. Don't do anything else. Just download it on your computer and get it open. Okay, so this is the first item in the assignments area. So download it, open it up. Let's see, what are we doing here? And when you open it, it should look just like this. This is what you should have. Everyone there? Okay, so here's what you're going to do. If you notice, if you take your cursor and put it on top of the red dot, it'll turn into like crosshairs. If you click, you can drag the dot. As you drag the dot up here in the command lines, It's keeping track of quantities A and B. Do you see that? A is the x-coordinate of the current location of the point, and B is the y-coordinate of the current location of the point. So A is x, B is y. Okay, and then there's this relationship of A and B, A squared plus B cubed minus 2AB. And so right here, this is keeping track of the value of that quantity based on what A is and B is based on the current location of the point. Make sense? So here's what you're doing. You're going to move this around and you're going to look for, you're going to find points where that expression in the third line is equal to 7 or between 6.95 and 7.05. Okay? So I'll find one here. We'll do this together. So I'm going to go right, I'm going to find one right. Got one. Okay? I got one. So it's at x equals 3.39 and b equals 2.17. So you don't have to write anything down, but then on the sheet that I just gave you, you're just going to go on that sheet and you're going to go to about 3.39, doesn't have to be perfect, and 2.17, which I'm saying is about there. I'm going to plot that point. So now this is your graph paper. I'm demonstrating what you're going to do in your graph paper. I'm going to plot that point. Just guesstimating, right? 3.39, 2.17. You don't have to write any numbers down. You don't have to do any calculations. So the goal is we want to find every point and plot it. Okay? So we want to move quick. So we'll do one more together. So maybe there's one over here. Let's see if we can find one over here. Okay, I found another one. 6 points. So I got to 6.97. That's close enough. All right. So now I'm going to take my graph paper. I'm going to go to my graph paper, and I'm going to go to negative 1.48 and 1.12. Boom. I'm going to plot that point. So you don't have to write any numbers down. You don't have to do any calculations. But we want to find all the points. So this is rapid fire. Find points that are close together. Find points that are far apart, such that that equation is equal to 7 or within this range, close to 7. As soon as you find one, take your paper, look at the coordinates, plot that point, and then find another one. So the goal is to maybe in 10 minutes or 7 minutes to have 20 points or more. We want to find them all, okay? Is the task clear? Okay, another thing, don't change any of the command lines, or don't add command lines. Just do this task that I'm telling you. Just move the red point until you can find one that's at 7, plot it on your graph paper, then move the red point again until you find another one. Anybody have a question on what you're doing? Yeah, so all the blank graphs are in the back. Can we just pass those up? Pass the stack of graphs, just pass them up. Okay, 9 minutes. See if you can get 20 or more points in 9 minutes. Plotted. Okay, if you can't, so we're going to have some people working together. So if you don't have a computer, find someone who does. And then if you have a computer, allow sharing. Who needed a sheet? Where are the rest of them? Everyone got a sheet. Everyone can see a screen. Everyone see a screen. Someone who's got it. Tanner, you want to come up here and work with that?
Sure.
you got a pad? Is it, but you have GC on the, you got it to work on the pad?
I'm gonna see if I can.
Okay. Andrew, can you find someone to work with? Everyone that's looking at a screen.
Yes.
What's that?
Oh, you said everyone was.
Everyone is looking at a screen. That's the protocol. Everyone's looking at a screen. Okay, 3 more minutes. 3 more minutes.
4? Remember? No, 7.
Let me see your plots. I want to see lots and lots of points. Good, good. Look at this.
4.5 is a weird one.
No, 4 is the weird one.
Okay.
Go to the negative side, 4. I just haven't seen a processor. This is 4. And it's going back up.
You sneaky fool.
Click and drag.
Okay, so try to get at least like 3 points in all 4 quadrants. See if you can find at least, there are at least 3 in all 4 quadrants. So if you're, it's okay to do some close together, but then we want to get a kind of a macro image as well, like a big picture. So try to get some in all 4 quadrants. Okay, stay on task and look at your quiz later. Stay on task.
2.14, 1.69, you get bottom already?
2.1 positive?
Yeah.
Positive 2.14. Negative 1.69.
Okay, that's 3.5 quadrants. They're negative over here.
There you
If you're working with a partner on one computer, trade roles. See if the other person can find some. Ooh.
I've got 2 and every quad. I have 1.
Negative 5.84. 1.1.
That's why you have to click it again.
So I can kind of see
Click it. You have to click it. Oh,
Okay, go for points in all 4 octaves, all 4 quadrants.
small. Where are you at?
Seating.
Where are you at? Negative 3?
All 4
You
quadrants.
want 1.5 quadrant? 2. Go for 2.
Negative 2.
Stop passing. Stop passing. Pass it. Yes. Yeah, it's like maybe 2.22. Close to a half.
Another one.
Susie.
All this over here. So between the spot.
So one goes like here. Goes right there. The other one.
Staying here today? Josh. Where are you? Coming. Connor. Schmidt?
There's another one here. Do it.
Is it gonna be above
Okay, stay focused on the facts. Quiz later.
Okay. Negative 3.7.
Oh, Sharon. See Wayne. Eric. Chen Ruiz. Rohit, Tia, Nancy, Shmeen, Lauren, Lionel. Everybody have a quiz for Friday? Oh, you are here. Waiting in the corner. Okay, did anyone find all the points? Did you find them all?
Can't find them all.
We have like 22.
You did 22.
Ideally, it should be points.
Okay, so let's all look at our quiz so we can get that distraction out of the way. We're going to get your quiz out and then we'll put it away. So the quiz, there were 30 points possible, but you still got a score out of 20. Some of you got 28. Some of you got 4. Some of you got less than 4. Okay? So I'm going to be putting together your current grade this week. Okay? That may or may not include the mastery, depending on how soon I can do it. I prefer to do it sooner. That won't include the mastery. So, so you had 30 points to get 20 for full credit, and lots of you got a lot less than 20. So your approach to the course needs to change. Your approach to the course needs to change. You're not putting enough time out of class. You can't just wing this course and do well. Okay? But lots of people were over 20, so we have a wide range. Any questions on the quiz? Okay, so let's put that away, and then let's go back to our task here. Anybody find all the points?
No.
Want to keep going? Should we get all the points? Okay, why not?
There's going to be.
So some of you are saying there's going to be an infinite number of them, and that's right, okay? There's going to be an infinite number of points such that that expression equals 7. Okay, there's going to be an infinite number of them. Okay, and so what's the point of this exercise? What is the big idea to taking all this time to find these points? Anybody? Yeah.
I think it's trying to prove that there's way too many points to try to just find them by hand.
Okay. Well, that is an idea here, but it's not necessarily the biggest idea.
Trying to show us a multivariable function.
Okay, what's that?
It's trying to show us how to graph well, not necessarily graph, but how a multivariable function graphs out.
Okay, so how a multivariable equation creates a graph. So if we wanted to show all the points, how could we do it? Anybody have how could we show all the points? Graph what?
The line, that equation,
Tell me exactly what equation you want me to graph.
will be a squared plus b cubed minus a to the b.
That won't work.
Minus a to the b. Well, that's just an expression.
It has to equal 7.
Is that a hand, David? I know. Okay, go ahead.
I figured ways to graph that would be that has A and B equal to X and Y.
Okay, make A's and B's equal to X and Y. Okay.
Set it equal to 7.
Set equal to 7. Kind of like that?
Yes.
Is this the same thing as what you were doing? It's every X and Y coordinate such that that expression is equal to 7. So your points should have been forming this curve. Were they forming this curve right here? Lots of you I saw had it. Okay, so then tell me about, I'm going to take this point right here. Okay, so tell me about the coordinates of that point right there. What can you tell me about the coordinates of that point right there? This is the big idea here.
That they equal 7.
The coordinates of that point equal 7.
No, when they're plugged into that.
Adonijah,
When they're plugged into that equation, it'll generate 7.
when what's plugged into that equation?
Your x and y coordinates at that point.
Okay, when the x and y coordinates of that point, they will satisfy that equation. So if you put the x and y coordinates in to that expression, you'll get 7. Tell me about this point right here. Tell me something about that point. Sharon, can you tell me something about that point? If you plug in the x and y coordinates, you won't get 7. Tell me about that point right there. Katie, tell me about that point right there. Okay, the point can't equal 7. What do you want to be 7? Right. When you take the x and y coordinates to that point, it will satisfy that equation. The left-hand side will equal 7. This point right here. Marcus, tell me about this point right here.
It doesn't equal 7.
A point can't equal a number, okay? A point is a location. So tell me about that point right there. You don't know, okay? Andrew. Right, so if you take the coordinates of that point, the x and y coordinates will not satisfy that equation. Okay, so tell the person next to you, what does this curve represent? What does this blue curve represent? Tell the person next to you, go.
All combinations of x and y equals 71 and 20.
Well, it's not a function.
Well, yes, so that's plug into 7.
Anyway, X and Y coordinates in the back.
Ah, there you go.
So this equation is true on every point where
Okay, so let's practice. So remember, points are not values. Point is the thing you're looking at. It's the location. It's that red dot. So when we make a statement, we want to use good language to make a statement about what is that blue curve. Who wants somebody new? Who wants to tell me what that blue curve is? Okay.
all possible X and Y coordinates that would satisfy the equation.
He wants all possible x and y coordinates that would satisfy that equation. Stanley.
I guess you could say it's all possible pairs of X and Y coordinates that, when plugged into the equation, will equal 7.
Right. Okay. So this equation is, so when you look at a graph like that, your image of it should be the the points that you plotted. How many points? Infinite number. Okay, so when you see a graph, your image of it should be a locus or a set of points. Which points? One more person. Which points are they? How about Daniel? Which points? So an equation is a set of points, just like you were plotting as many as you could. Which points are this blue curve?
Well, they're the x and y coordinates that satisfy the equation to make it equal 7.
Right. So it's all points whose x and y coordinates will make that equation true or satisfy that equation. That's what an equation is. Okay? It's a really big idea. So if we got a point off the graph, what about its x and y coordinates? Not going to make that true. If it's a point on the curve, it makes it true. The x and y coordinates of that point make it true. If it's a point off the curve, the x and y coordinates don't make it true. Okay, so now I want you to let's talk about rate of change. So first of all, is this a function?
Yes.
Is it a function?
No.
Use your pencil tip.
There's input.
So what is remember what the rule for a function is?
Or vertical line.
But what's the idea?
Only, no, vertical line was determined.
Yeah,
Each input can only have one output.
yeah, and that's what Andrew says too. Okay, so Jacob, sorry. So does every input or every x value just have one possible output y value? No, it doesn't. So this equation creates a graph that's not a function, but can we still talk about rate of change at any given point? Yeah, we still talk about rate of change. So I want you to estimate the rate of change when x equals 3. Do it with your partner. Estimate the rate of change when x equals 3. Go.
Because it's derivative here.
Why is this question different than ones we've had before?
Because there's three rates of change of 3.
At x equals 3, how many points are there that satisfy that? 2 points.
3 points.
3 points. You got 1 point down here, you got 1 point here, and you got 1 point up here. So I'm gonna draw them all. So actually, before we do that, let's get those. Yeah, let's get those. So if you still got it open, you can. Let's see here. Oh, 6.98. Stop. Takes a steady hand. There we go. So here's the first point. 3, 0.344. Next one. Oh, I should have been doing that all along. Okay, so yeah, instead of using the red point, I should have used the crosshairs of the graph. 3, 2.26. And 3, negative 2.6. All right, so if we want to estimate the rate of change when x equals 3, well, we got 3 different estimates to make. Go. So you're making 3 different estimates. An estimate of the rate of change here, an estimate of the rate of change here, and here. Work with your partner. Estimate the rate of change at each of those. Figure it out by knowing what rate of change is. Understanding what is rate of change. What does that number mean?
It's negative 1/3, 1 negative. There's no twos here. Oh, right there. I just I can barely see the after 3 points really hard. So I'm right at the end of the one. And then you can use the bronze. I can use it to 101. Sure. Actually, something wrong with bigger.
What's our general idea of rate of change?
Slope.
Change in y over. And what does that mean? Change in y over change in x. Can you explain what that means?
It's relative size changes in y compared to changes in x.
Okay. How about someone in the back? Very well said. How about someone in the back? What is that ratio, change in y over change in x? What does that mean? Anybody give it a shot? How about Daniel Herder?
Well, in this case, it's
In any case. In any case, what does that mean? The ratio of changes in y to changes in x.
right. It's saying that to stay on the function, the amount of change in one quantity versus the amount of change in another.
Okay. All right. Yeah, Chelsea. Right. It's how big changes in y are relative to the change in x there. Remember that quotient? What division means? It's relative size. It's how big the change in y is relative to a change in x. Okay. So we can use graphing calculator here to really. So let's start at this first one. How can I use graphing calculator to get a really good estimate of what that rate of change is? What can I do? Adonijah.
At another point really close, but just a small change in x.
Okay, so if you want to get a point really close,
Zoom in.
zoom in. And we can zoom in enough so that the graph is like what?
Y3 change graph.
Right, and so we can use what's called local linearity. And if for a small enough piece of that curve, it's virtually constant rate of change. It's virtually a line. Okay, so I've got this point, 3. I'm off the point now. But here's my point. Oh, I need more precision here. Hold on a sec. There we go. Okay. So here's 3 and our 2.26. So I can get a good, here's 3.005, maybe. At 3.005, at 3.005, I have
2.261.
but we want to, so, let's see here. Sorry.
Did you increase your precision?
All right, so let's, if we want to get this to be accurate, what we need to do is, at 3, it's 2.2618. Okay, and then at looking for, doesn't really matter. There we go, 3.007. $2.26069. Okay, so what I want you to do is, based on those 2 points, the first point at 3 and the second point at 3.007, now get a actually a very good estimate of the rate of change at 3. Go. So what, and see how close it is to what you estimated from before. So now use these 2 points. Estimate the rate of change.
Maybe.
So you can use graphing calculator to do that, right? Graphing calculator is an excellent just numerical calculator too. What should I type in to find it? Let's see here. Somebody who's not. Kaiser, what should I type in here to estimate the rate of change at 3? Can you tell me? No. Let's see. Tunzi, what should I type in here to estimate the rate of change at x equals 3 right here? What should I type in? What calculation should I do to get estimate the rate of change at this point? What's that? Just put the number. What number? .007 minus 3. That's at what? That's delta x. Okay? So I want to do it all in one line. So where should the delta x go? Let's see, Autumn, can you tell me?
You're gonna just subtract the y value. So I did 2.26069 minus 2.2618.
Minus 2.2618, okay.
And then divide by the change in x, which would be just
Oops.
0.007.
It won't. They're attached. Graphing calculators.
2.2613.
I had to do it on different lines, but
Okay, not gonna put the decimal in there. Yep, okay, and then what?
divide by 0.007.
It's just that, which is 3.27.
Okay, got a number. What number do we get?
Negative
Tell the person next to you what it means. What does that number mean? How does it relate to the graph? Go. What does that number mean? How does it relate to the graph?
x equals 3. The average rate of change is -1.
Rate of change is not a sufficient answer. What does that mean? So, rate of change is not sufficient. What does the number mean? Talking about the quantities y and x.
X change 1 y. Change in y. Graph what?
And then, how does it relate to this picture? Why does it make sense with the picture that we're showing here? Why does it make sense?
Oh, that way, okay.
Okay. Beth, what do you think? So what
Y
does that number mean and how does it relate to this picture?
The y values are changing negative 0.159 times as fast as the x.
She said the y values are changing negative 1.59 times as fast as the x values. At that point. Agree with that? How does this show that? How does what's happening, how does the graph show what she just said? That the y values are changing negative 0.16 times as fast as x. Yeah.
As the x values increase or go to the right,
Okay.
the y values are decreasing the same 0.0 or 0.15 times maybe.
Yeah, exactly. If you go, so for a change in x, for a change in x right there, what's the corresponding change in y? First of all, is it down or up? Down, because it's negative, right? And is it larger or smaller than delta x? What fraction of delta x is it? Yeah, it's like 15% of a decrease compared to how much delta x increased, right? So for a change in x, y is going down about 0.16 as much as x. Or y is decreasing 0.15 times as fast as x is increasing. So you can see that that change in y right there is about negative 0.16 times the change in x. Okay, anybody have a question? So we could do that for the other points, but let's do something else. Anybody have a question on that? Really important. So what does rate of change, that number, rate of change, what does it mean? This conversation is a conversation really we've been talking about all semester. So keep practicing it till we really get it. So how can we, so that was all estimation using the graph to kind of pick off points and estimate with delta y over delta x. But we also want to have kind of a mastery type way of approaching this problem. Can we get a closed form rate of change function that would give us that rate of change? So here's how we'll do that. So what is our equation? It's x squared plus y cubed minus 2xy. So I'm going to do this fast because we don't have much time, but we can do it. So we don't have y as a function of x anymore, but we can still take the rate of change of both sides. Is it okay? So all I did was I took that equation and I said, what's the rate of change with respect to x of the left side? Well, then it would equal to the rate of change with respect to x of the right side. So now, what's the big picture? Sum rule, right? So we just do them one at a time. What's the rate of change of x squared? 2x. Okay, now, even though this isn't a function, we can kind of pretend that there is some equation, not a function, but some equation where y equals some equation of x's. So that y is some equation of x's. So now when we do the derivative of that, it's really like what we have is the equation of x cubed. So Connor, what's it like?
Chain.
This is like the chain rule, right? So when we do a rate of change that has y's in it, every time we get the rate of change of y, it's going to be chain rule because y is an equation of x's. You see? So what will that be? Plus 3y squared times, right, times whatever that rate of change of y is. Okay? Now what about 2xy? Minus? What's the structure? Product rule. So we'll have the first times the rate of change of the second
plus 2. So times the rate of change of the first. Oh,
plus the derivative of the first, which is minus 2
and just y.
times y. Okay? And then on the right side, we have the rate of change of 7.
0.
0. Okay? So now, what are we after? We're after this right here, right? We want to know what's the rate of change. That's what we were doing when we were estimating at that point up there. So what do? We take all the terms that have this and keep them on the left, and every term that doesn't have it, we move it to the right, so that we're trying to solve for this right here. So we have 3y squared. You're going to have homework like this. I suggest you get this example. So I'm going to move, now I'm moving everything that doesn't have a dy dx, I'm moving it over to the right. So minus 2x plus 2y. Again, I'm trying to solve for dy dx so I can factor it out. Can I factor it out and divide at the same time?
Only if you.
I mean, yes, I can, but will it be okay with you?
Yes.
That's what I'm asking. So I'm factoring out dy dx, and I'm going to divide by what's left, which will be 3y squared.
Minus 2x.
So look, we have a, what?
Rate of change function.
We have a rate of change function. But look, because the points depend on x and y, not just x, so does our rate of change. So what we want to do is we want to plug in what was our point that we got?
3.
X equals 3, but we need the y too, because remember there's 3 points at x equals 3. What was the y coordinate that we had?
2.18.
So I'll set up a rate function. I'll give you back the time on another day. Okay, so set up the rate function. Minus 2x plus 2y all over 3y squared minus 2x. Oops, this is a function of 2 variables, sorry. So it's going to be x and y. So this rate function is a function of 2 variables, x and y. So now I'm going to evaluate r at, what was x? 2.2618.
Yes.
Look at that, what do we get? You see? So now when you plug that point into that rate function that we just found, what do you get for the rate? Negative point, it's virtually negative 1.58, virtually what we estimated when we did it with the 2 points. Okay, this is called implicit differentiation. When you have an equation of x and y that's intertwined together, you do this process, which is implicit differentiation, which still can get you a rate of change, but you need x and y to plug in to get that rate of change.